Welcome to this talk on Duke Goes Serverless. If you're not here for serverless and serverless with Java, you're probably in the wrong room, so you might just leave. But if you're here for Java on serverless, you're in the right place. So some words about me. I'm a Java champion. I'm an Oracle Groundbreaker ambassador. I'm involved in the Java community process in the executive committee there, as well as leading a spec called MVC through the JCB. I'm also in the Jakarta EE working group, where I'm involved with the Jakarta EE efforts of moving Java EE over to Eclipse Foundation and develop it further in a open source way. That is at the Eclipse Foundation. I'm also a Apache NetBeans committer, and I run a local Java user group in Malmö in Sweden. And those of you who know me know that I usually do talks on Jakarta EE or MicroProfile. I won't be covering it here today, but I'll just say that we have a buff directly after this one on Jakarta EE, so if you're interested in that, just join us there. So what I'll do today is to go very quickly, just throw a couple of serverless concepts out there. And then I'll dive directly into the implementations and show different fast options out there, and just show the similarities and differences with the different options, and just show how you do it, and just go through and look at some code. And then a short summary at the end. So what is serverless then? Well, first of all, it's a very bad name. And why is it a bad name? Well, as you'll see later, there are still servers. It's just that these servers are somebody else's. So the good thing about this is that we don't manage them ourselves. We let everybody else or somebody else take up the setup, the scalability, the infrastructure around it. It's somebody else's job. So we can just focus on the business value and the content on the actual functions. So what serverless really is, it's not serverless, it's just no server management. And that is because, as I said, it abstracts away the underlying infrastructure, so you can focus on the code and only the code and build the applications, and you can do it faster than you ever could before, because there are literally no startup times, and you can just write a short piece of code, throw it on some infrastructure, and it executes. It scales automatically. So a function by nature is that if you have two calls coming in at the same time, it will instantiate two instances of that function. So if you have like a million of calls coming in at the same time, it will scale out to a million of invocations, and it will turn down, and it won't spend any resources while it's not doing anything useful. And that brings me over to the payment model. So you only pay when the code is running. So that is when your function is executing. So if your function takes a week to execute, well, then you pay for a week of computing time. If it takes a millisecond, you only pay for a millisecond. And then next time it's executed, you pay for that millisecond. And it's event-driven by nature. So the code is running in response of events. So it could be HTTP triggered events, which is the ones I'll demo most of today, or it could be triggered by timers or something else. And what I usually, when I came across functions in my project, what we usually end up using them for are batch jobs. So we just have it as a timer scheduled running in some infrastructure that kicks off a chain of functions, and just doing some batch scripts over the night, for example. There are no new languages. So serverless is open and familiar. You can use whatever language you have in your pocket and what you are most familiar with. And it's also known as functions as a service or cloud functions. So dear baby has many names, as I say. So what about Java functions then? And how about performance with Java functions? Everybody knows that Java is slow, right? And Java is slow with startup time because the VM has to load, and it has to load all these classes and everything. So Java may or may not be the best option for serverless, but we will see that it's actually getting better and better over time, and it probably can end up being a very relevant alternative for serverless. But first, how about frameworks then? Can I use Spring Framework, for example, in my functions? And yes, you can, but as with the other things, be aware of the startup times, because if you add a bunch of things that your function depends on, it will start up slower. It has to load all this stuff, and the more you add to it, it will take longer. The rescue here is GraalVM. So GraalVM solves a lot of this stuff. Still is not 100% compatible with the entire Java language, but you can do most of it using GraalVM. And if your libraries also are enabled to use GraalVM, then you can drag in a lot of frameworks and still have pretty decent startup times. And the memory footprints goes down as well, because GraalVM helps you to compile it to native images. And here are some examples I stole from a slide from Red Hat, where they present the startup and memory footprint of Quarkus. And as you see here, the memory of a Quarkus native compiled typical REST application is like 13 megabytes, whereas if you have the traditional cloud native stack, is like 100 or something megabytes. And if you look at the boot and first response time, you can see that for typical, you're talking milliseconds with Quarkus, and if the different other Java versions are typically on seconds. So GraalVM is actually solving most of the issues that we traditionally talk about when we talk about the startup times of Java with functions. So let's look at some fast implementations then, or functions as a service. And I'll just dive directly into the demos and do some coding here. But first I'll just introduce them. So the most familiar one is probably AWS Lambda. So how many are using Lambdas here? A couple of, are you using Java or Node or something else? Both, yeah. So I'll just quickly, you can see with Lambdas, it supports a couple of languages. You can use Node.js, C#, Python, and Java. Currently, they support Java 8, but probably they will support Java 12 soon. So let's just look at how we can do it with AWS. So I have this very simple project here called Lambda Duke. And what it does is to just say hello to, oh, sorry, I'll show the screen as well. There, now we can see it. So I have this very simple hello function that just takes in a person, gets the name of that person, and returns hello to that name. So it's practically hello Duke or hello world, or however you would put it. The way it's configured is it's using the Shade plugin and the AWS Lambda core Java libraries. So you practically just build it to a jar. And I'll just check if I've done that here. So if I go into the, let's see if I have the Lambda Duke somewhere. It's there. Clean. This one is on Java 8, so hopefully they will support the new version soon. So it's pretty fast to build. You get a jar file there, and then you can use the client tooling of the AWS to deploy it, or you can simply go into a console here and create a function. Let's call it Open Duke, since we're at Open World, and choose we're using a Java there, Java 8, and create the function. So it's doing its work. And of course, this can be used scripted using the AWS client tooling as well. So we have the OpenDuke, and I can upload my jar file here. So I'll just choose the jar file. Just have to find it here. Where are we? Demo, function Duke, Lambda Duke, target, and we have the Lambda Duke snapshot. And as you remember, the signature of my method is it's called hello. It has the handle records method, and the package name is EU Agile Java, which I usually use for my demos. So I just have to update the package here, so I have a fully qualified path to the method handling my request. And that's about it. So just save it. And if I want to test this function, I can configure a test event, say, call this one hello Duke. Oh, sorry. And as you remember, the object I expect should have a name variable, and it should be called Duke. So the person object I'm using here just has a name. So I'm sending in a JSON with a name saying that the name is Duke. So I create this test event, and when I have this test event here, I can execute the test of Duke, and you can see here it says hello Duke. So you see it executes pretty fast, it's pretty neat, it's easy to set up, and you can add here all the kinds of triggers and put it behind gateways and however use all the AWS infrastructure you have there. And as you see, there are very little boilerplate code around it. You just have to implement this interface, and then you're good to go. So Google, of course, has Cloud Functions as well. They support Node.js, Python, and Go. They have Java in a preview. Unfortunately, I've signed up for it, but I haven't been given the account yet, so I cannot demo it here. But Google Cloud Functions will shortly support Java as well. Google has another initiative called Knative, and that is more or less a set of components used to build serverless applications on Kubernetes. So you can use all the cloud native infrastructure that comes with Kubernetes, and it supports everything like scaling and auto-scaling and clusters and builds and everything. And of course, Kubernetes, it's container-based, so you can write it in any language that you can drop into a container. So it supports Java as well. Microsoft Azure has their Azure Functions, and they support also C#, F#, JavaScript, as in Node, and also Java. And Java was actually announced as general availability in February this year, so they support it fully in Azure. It's not a preview anymore. So I'll quickly demo Azure Functions. I'm never sure if you're supposed to call it Azure or Azure, but I think people mix it up a little, so do I. So let's look at the Azure function. The function itself, oh, sorry, there we go. So the function itself is a little bit more verbose than the AWS example. You don't have to implement any interface, but you annotate the function with a function name, give it a name, and you annotate the trigger of the function. In this case, it's the HTTP trigger on a method getter post. And I get the context the same way as I would get with AWS. And in this case, I get the name from query parameters from the HTTP request. and I just fetch the name from the query, and just says hi to that name. So the business logic is similar. It's a little bit more boilerplatey around it, but you'll get used to it. What Microsoft provides are the Java libraries the same way as Amazon does, but they also have a plugin. So you can use Maven to build and deploy and run your function. And I'll demo that here. So in the Azure Duke, I'll Maven clean package to build it, as you would do with any Maven based program. And since they offered this Azure Functions Maven plugin, I can use Maven to test my function locally. So I can write Azure Functions run. And it will, what did it say? Is it functions? So it starts up on localhost, and I can navigate to the HTTP endpoint of my function. And as you remember, I had it in the method. It would say that please pass a name on a query string or in the request body. So here it says, please pass a name. So let's do that and say, name is Duke, and it says, hi Duke. So it's very quick up and running to test it locally. If you want to do a deployment to Azure, if you download the Azure client tooling and log into your account, you can use the Azure Functions deploy and deploy it directly to your cloud account if you have some there. And I won't do that now because of, the network will probably be a little bit too slow to do that. But I'll show how it looks in the Azure portal. So they have the notion of function apps. So you create a function app, and here you can see the Duke's function. That's the name corresponding to the annotation I had in my Java class. The other things that kind of identifies these is the Azure Duke, which is the name of the app. That is something you configure in the POM file. So you typically call it the function app name and say which region it's going to run in, and et cetera, et cetera. All of this can be overridden later, but this is just to get it up, to test it here. And I can run the function just directly here and see the result, like hi Duke here, or I can run it in the browser by getting the URL, saying here and saying, and name is Duke, and it will say hi Duke. So it's pretty convenient. It's a nice framework, and it's very easy to set up the function. It's more or less just 3 clicks in the portal and you're up and go. Or with the client tooling, you just use a template and it's there. So now we've seen some more proprietary solutions, like the AWS Lambda is you're tied into Lambdas when you use that, as with Azure Functions. Then we have Apache OpenWhisk, which is an open source at Apache. It supports a wide variety of languages, among them Java. And one of the providers who have chosen to go this path is IBM. So they offer the IBM Cloud Functions, and that is built on top of Apache OpenWhisk, so they also support the same range of languages. And I'll use the IBM tooling to do this demo. So, and I'll remember to mirror the display. So the IBM code is also super simple. It is a POJO with a static method And they are using JSON for JSON serialization. And here it takes in a JSON object, get out the name from this object, and writes a JSON back saying hello name, or hello Duke, or whoever it is coming in there. And this one also doesn't need any other dependencies and the ones you drag in. So this is just the JSON to get this JSON serialization, and apart from that, it's just a shade plugin. So there are no Java or libraries from IBM or OpenWhisk that you need to have. You can, of course, put them in there, but in this simple case, you don't need anything other than for JSON serialization. And this one is, you can use the IBM tooling, which is built on top of OpenWhisk. So I'll use the IBM Cloud, I think it's FN list. So it lists here two different functions. One called Hello Java and one called Demo Java. So I'll just remove the Hello one and do a redeploy of the stuff I've created here. So you see that it works. IBM Cloud FN delete. Is it FN remove? Oh. Yeah, so luckily I have this kind of cheating README file. So all of this is available on GitHub. So if you need some if you want to look at the code, you can just go and look at the README file, how you do the deployments and stuff. I'll just do a new call this one OpenJava or OpenDuke. Let's call it OpenDuke. So what I'm doing here is to create a function called OpenDuke and just point to the jar file that is built for me by Maven. And I should be able to invoke this function by just saying OpenDuke. So I give the name of the function. I say the action is invoke this, and I give it the name world, or since we're doing Duke with the others, I'll use Duke here as well. So it should say hello Duke. So you can run it locally, and the same tooling will be able to run on IBM Cloud as well. But as with Google, I haven't received my credits there yet, so I won't be able to do that. So then there's another interesting one called OpenFaaS. I did the mistake in my last talk to say that they don't support Java yet, so they pointed out that yes, we do. So this morning I created a demo where I showed the Java support in OpenFaaS, and they actually support Graal VM as well, but I didn't have the time. The creator of this, Alex, he pinged me on Twitter and said, did you try the Graal template? And he did it half an hour ago, so I didn't have the time to prepare that demo. But next talk will be with the Graal support here as well. And it's a growing community of contributors, and they're very active, and they are increasing the number of languages and platforms they support as we go. So check out openfaas.com. And I'll demo OpenFaaS. And this one needs a little bit of preparations. So. And here is kind of the thing that comes in that, yes, I'm doing serverless, but what do I need to do before I'm doing some serverless things? Well, yeah, usually if you run locally and you don't have the kind of stuff running already on a machine, you have to start the server, and that's kind of the stupid thing here, but that's what you got to do. The function in itself is super simple. Here also, it's just a handler that takes a request and returns a response. And in this case, I just write hello world. It's using Gradle. I'm not a big fan or user of Gradle, so I have no clue how that goes on, but it works. And you can probably do it in Maven as well. But what I have to do here is, to get started, is to start up, we can run it in various platforms, Kubernetes or whatever, but the easiest thing to get started if you're doing like local on your computer is to use Docker Swarm. So what I'll do here is just say Docker Swarm init. Okay, I already have it running apparently, so I'll just go away. Docker Swarm leave. Let's force it out. So let's add here. I get a token from it here, and let's just start it. Did it go? I think it should be up and running. Yes. And so I've started a swarm, and then I just have to deploy the OpenFast stack to it. There we go. Soon up and running. So this is typically something you would do once, and just have it running on your development environment, and you wouldn't have to sit and wait for this. Well, I just wanted to show the steps you need to do. So it's okay, let's copy the password, and let's do whatever they say you shouldn't do. So I'll just say fastly login, and give it the password there. So I'm logged into the client tooling, and let's check out the portal. It takes a little while to start up. So while we do that, I'll just do the build of one function and deploy it to the local fast portal. So I'm using the fast CLI tooling, and I think it's just build. Let me just check for sure. So yeah, it's Fastly build, and I just point to the OpenFast YAML, and while we do this, we can look at it. It just gives you the version of your application. It gives us a name, where the OpenFast gateway is running, which version of Java. This is Java 12, and where it's the handler project, and that's the OpenFast Duke is the project where the handler class was located. And as soon as the build is done, I can do an fast CLI push. So I push it to my local Docker, and then I can deploy it to my local running fast gateway. CLI deploy. And I had to give the file, let's see. Give it the file. And as you see, I get it's deployed, and it's got this URL, so I can just navigate to it. Let's see if it starts up. I think there are some password thingy, yeah. I have to take the password that I had. Okay, it's not the same. Let's see if I have it here. Copy the password, password, and sign in. So I'm in the OpenFast portal, and you can see I have the OpenFast Duke application, and I can do a invoke here, and you see it responds pretty quickly and saying hello world. I can also do that from command line by writing fastly invoke. Let me see if I have the I wonder if I have to take the YAML there as well. OpenFast. Okay, so I can't remember exactly how you invoke it locally, but you usually can test it here in the portal, and you can also test it in just accessing the URL. Which will say hello. Sorry. So that's OpenFast. They have lots of templates, so it's pretty cool playing around with. The last one I'll go through is FN project. And FN supports a wide variety of languages themselves, among them Java. And FN is open source. And what's interesting about FN is also that this is what Oracle has chosen for their Oracle Cloud. So I'll demo this in Oracle Cloud. And to do that, before I do that, I'll just remember to go out of this one. Leave. So the FN project is also open source. And it's actually pretty similar to the OpenFast project. So I'll just maximize this one. So the function is just a very simple function called hello function. It has a method. You can call it whatever you want. And here I'm not getting the input from the request, which I could do, but in this case I'll just show how to get it from environment variables to see how you can configure a function. So here, if it doesn't have an input, it will take an environment variable called name and use that one if it can find it. And this one is built using Java 9. And you have the FN project APIs libraries you can use for, and you have some test dependencies. Otherwise, it's just compiled to a jar file as usual. But with FN, you usually use, you can use Maven to run the tests and build and stuff, but you usually use the FN client tooling to do the builds as you do with OpenFast. And with the FN has a YAML descriptor similar to the OpenFast one, where you say the version is automatically increased by the FN tooling. And then you just give it some name, what versions you're using, how you want to trigger it, in this case, an HTTP trigger. So you have some metadata around there. And to create this kind of thing, in the first time, it's just simple FN create project, and and you just say, this is a Java project, and it will create this stuff for you. So I'll just demo how this one works. First, I'll run it locally, and then I have to start my local FN server. So it's pretty quick. It's up and running on port 8080. And then I can deploy this app. So I'll just use the history. So I'm saying FN deploy app. And I say it's FN Duke, and I want to deploy it locally. So you see it bumps the version to 86. And in the server, you can see something is happening. And I can do this, invoke this function locally. And here, I'll just check that I'm writing it correctly here. So here I give it the name of the function app and then the name of the function. So as you remember from the Azure case, you had this function app name where you have your function. It's kind of the same structure here as most of them have. You kind of have this function app and function. And in this case, they are called the same thing. So I invoke FN, and it says hello world. And if I want to configure this one, I can say configure function. I'll just have to set check and I give it the fn Duke, and say the name variable should be Duke. What did I write wrong? Oh, it's configure. It's config. Thank you. So I configure, and if I now invoke it again, you'll see it has picked up the new environment variable. And this one is running on a local host, and you can see it does things. So what if I stop my local server, and you'll see it's now it's not available for me anymore. So let's see how should I do this if I want to run it on Oracle Cloud. So I'll then use context, OCI, something I'll just context list. List context, I think it's. So I'll see I have other context here. So rather than using the default one, which is at localhost, I'll use the context pointing to the Oracle Cloud. So now I'm using the Oracle Cloud context, and I can do the same thing to deploy my function. But here my app is called something else. It's called function Duke, and I can show that in the UI. I just have to go into functions. So, but while this one is logging in, I can just do this deployment. So you see it bumps the version to 87, and you can see it's okay. It doesn't have access to. Okay, I have to log into the this there Docker login. So to log into this one, so I'm logged in now. I should have the. Oh, it's not local anymore. So sorry about that. There we go. So here you can see I'm pushing it to the registry, and it's bumping the version number and putting it up there. And if I now do the fn invoke, I have to use the name of the function app on Oracle Cloud, but it's the same function name. And since this is the first time it starts up, it has some warm-up time and takes a little bit of time. And while it does that, I'll just log in to my console. So I have my functions here. Let's see here if I can find it somewhere. Functions compartment. Function Duke is the name of the app. And as you can see here, I have the fn Duke app, which is deployed here. That was done just now. Sorry?
Is there a way here to create an event and invoke it from the console, like we did in AWS?
I'm not sure. I think they're probably working on that. So I haven't seen that. You can invoke it from your you can invoke it from your command line, and if I invoke it again now, it should be quicker since it now has been warmed up. There is, and I'll show you how to do that. And Oracle has a little bit of more security around this, their function offering. So you need to sign the requests. So what I have to do there is of course I can create the keys and do everything and sign it, or I can use some tooling that they have provided for us called OCI curl. And so it's kind of a Oracle Cloud Infrastructure version of curl. So I just have to set up my terminal with the right credentials, and then I have, as you saw in my, when I did the deployment, I got an address to, not here, but I have an address here where I can see somewhere I can see the URL of the function. Here. So I have the endpoint there, all this here. And what I can do is to use the OCI curl and call that endpoint with a GET request to the fn_duke trigger. And if you remember from the function YAML, that's the endpoint. So the /t is from the trigger, and this endpoint here is from the endpoint here. So I can copy that endpoint, and I can do this call here, and I will be prompted from passphrase because it's using my public key, which I generated from the Oracle Cloud. And if I enter that one, it should say hi world. And I can also here, as I did with the local fn, I can do fn config function duke. Was it another one? Fn duke name. Set the duke. Do the call again. And now it redeploys, so it's a little bit slower since it's been reconfigured. It's the same version, but now it says hi Duke. So, and here it is faster when it's been. So it's pretty neat. There was also provided by Oracle a Java library for doing the function invokes. So if you want to do it from Java code, you can do that. It's a little complicated, but it's basically the same settings as you would do in the curl, that you have to sign the request and invoke the function.
Spawn, let's say, 10 threads, and they will call that in parallel, and they will invoke 10 instances of that. Am I right?
Yes.
And is there a way on the console to define a function and upload a jar like you do in AWS? Because here you deploy it from the CLI.
Here I deploy from the CLI, that's correct. I'm not sure if you can do it from the console, actually. I personally like to do it from the console, but I'm sure if enough people ask for the UI support, you will probably get it.
I'm asking all these questions because I went to do the lab today, and I asked them if they have a lab to do that. I wanted to experience it.
Yes.
I'm familiar with AWS, and the lab started with all kind of stuff that had nothing to do with FN in my eyes,
Yeah.
creating all kind of definitions and environments, and then it crashed.
Okay.
I got to do anything with it, so.
Yeah. So the comment is that it's kind of cumbersome to set up. And I agree, there is, when you get a cloud account, you get a PDF that is like 17 pages long or something with instructions how to set it up. As long as you follow them and actually do exactly what they say, which I didn't, you should be able to get it up and running. I did it once, and I needed some help from them, and they pointed out where I did it wrong. But when it's set up, it's pretty stable. So I think it's probably targeted as the big customers who do this setup once in their IT department thingy, and it's not meant for like the regular developer to just play around with it in a couple of clicks. But it's kind of stable. It feels well brought together, and FN is I think it's a very nice client tooling to use. So.
Another question. So in AWS, I can sort of bring it together with other services. I can have things, other services trigger the function, like the queue service. And I can say when you see a package in the queue, you will read the package and work on that. Or if somebody puts a file in this bucket, you go read the file. Can you do things that does it combine with other services? Or
So the question is if there are support in Oracle Cloud for combining the functions or having triggers and having it triggered by other parts of the system. And I'm pretty sure there is. I haven't explored it or tested it out, but I would be very surprised if it weren't. There are API gateways and everything similar to the Amazon environment. Probably Amazon has been in this game a little longer and have done a better job at doing it developer friendly. But I think just from last year to now, Oracle has done a pretty good job at doing it more developer friendly than it used to be.
The other thing is maybe originally they didn't intend to do it. They wanted it
So the question if they intended to have it in cloud or not, or if only the FN or... Yeah, could be. I don't know. I got access to the early build of the Cloud Functions in this winter, and they just launched the general availability of it, I think. So I think it looks promising. It certainly feels stable and good. So yeah, my time is up, I see. So I'll just go through a slide here to sum it up, and we can talk more afterwards. If I should sum it up, I would say Java on Functions works. It is good, it is cool, and with the new native compilers like Graal and et cetera, the startup times and everything, and what the cloud providers do to get the startup times down are showing that Java has a future as serverless or functions. Some thoughts around this is that we have these open source frameworks. We have FN, OpenWhisk, OpenFast, and there are probably others as well. Should something of this be standardized? Should we have portability? Should we be able to write a function and deploy it to AWS and Oracle and Microsoft and try it out there? Should we be able to just grab it? Or is it okay to have this vendor proprietary things? Should there be some standardization? Should we have Jakarta Functions? Or is it just a stupid idea? I don't know. I'd like to have that discussion sometime. And what should we standardize? So it's some thoughts. Resources from this talk. The samples are on GitHub. And the implementations, I listed all of them here. And I'll distribute the slides afterwards. So this is what I showed today, and I hope you enjoyed it, even though some of the demos were a little bit shaky, but I think it went well. So thank you for listening, and I'm happy to take some questions. Otherwise, just grab me in the hallway and let's discuss Jakarta Functions or something else. Thank you.